Have you ever looked very closely at a bottle of Italian salad dressing? I have one here, and let's look at it. If you look, you can see that there are two liquids in the bottle, one liquid on top of another. This everyday observation suggests a fundamental question about liquids, and that is, are some liquids heavier or more dense than others? Let's see if we can answer this question through experimentation. Now, I use the word dense. What do I mean by that word? Well, dense refers to density. And when we are comparing the heaviness of objects, we should really talk about the densities of the objects. What is the definition of density? Density is the weight or mass of a material divided by the volume of that material. When you're talking about the density of liquids, density is the mass or weight of a liquid divided by the volume of that liquid. Well, what does this definition mean? Well, it means that the same volume of two different liquids can have different weights. Imagine having a cup of water and a cup of oil. They can have different weights. And this is what density means. Okay, let's return to our experiment. What we want to do is we want to add some various liquids to our glass, and we are going to look to see if the liquids have different densities. Let's start off by putting a quarter cup of water in our glass. And so that we can distinguish the water layer from the other liquids that we're going to place in the glass, let's color the water with some red food coloring. I'll add a drop of red food coloring to the water, and I will stir the water. And now let's add our water to the glass. Okay, and there's our water layer. Let's now add a quarter cup of oil to our glass, and let's see if oil is more dense or less dense than water. If oil is more dense than water, it will form a layer on the bottom of the glass. If it is less dense, then it will float on the water layer, which is red. Okay, here comes a quarter cup of oil. Now we can't color the oil, so it will be clear, and let me add it. Okay, you see two layers here. The oil layer is on top of the water layer. This shows us that oil is less dense than water. Or to say it another way, water is more dense than oil. All right, let's take some corn sugar, and let's take a quarter cup of corn sugar, and let's add it to our two liquids in our glass. And again, we're going to take a quarter cup of our liquid corn syrup. There's about a quarter of a cup. And let's color our corn syrup. And let's use green. I'll put a drop or two of green food coloring in with our corn syrup. And let me stir this thick liquid. As you can see in just a minute, the corn syrup is going to be green and thick. All right. So now I'm going to pour the corn syrup into the glass, and let's see what happens. Where does the green corn syrup go? It passes through the oil layer, it passes through the water layer, and it ends up on the bottom of the glass. What does this observation tell us? It tells us that corn syrup is more dense than water, and it's more dense than oil. Let's add one more liquid to our glass, and let's see where it ends up in our glass. I'm going to add some dishwashing liquid, and I'm going to tilt the glass so that I don't mix the layers too much. And I'm going to add what I think is roughly a quarter cup of the dishwashing liquid. That should be roughly a quarter cup. All right, where is that layer? If you look very carefully, just above the green corn syrup layer, you will see the dishwashing detergent. What does this observation tell us? It tells us that the dishwashing liquid is more dense than water and more dense than oil, but less dense than the green corn sugar layer. All right. Let's see if we can use this experiment to compare the densities of solid objects and liquids. Let's take some solid objects, and let me start out with a toothpick. And I'm going to break the toothpick into a small piece. And I'm going to drop this piece of toothpick in our glass, and we're going to see where it ends up. And where it ends up in the glass is going to tell us something about the piece of wood. So here we go. Let me drop it in. Okay? As you can see, the piece of wood floats on the oil layer. What does this observation tell us? It tells us that the density of wood is less than the density of oil. Let's take another solid object, and let's take a paper clip, and let's drop our paper clip in the glass, and let's see where it ends up. Okay, it passes through the oil layer, it passes through the water layer, passes through the detergent layer, and it's sort of just floating in the corn syrup layer. It's starting to drop down now. What this observation tells us is that a paper clip is more dense than oil, it's more dense than water, it's more dense than our dishwashing liquid, and it's probably more dense than the corn sugar because it does sink to the bottom of the glass, although it floated very slowly through the corn syrup, so the densities are probably fairly close. Okay, let's take another solid material and try to determine its density. And I'm going to add some salt to our glass, and let's see where our salt ends up in our layers. So let me just pour a little bit of salt in. Okay, it passes through the oil, passes through the water, and it slowly passes through the detergent layer, and it sort of is just floating in the corn syrup layer. So our salt has a density somewhere between our corn syrup and our detergent. One last solid material that we'll try is a piece of styrofoam. Here I have a styrofoam cup, and I'll just tear a piece of styrofoam out. Can you predict which layer the styrofoam is going to end up in? I bet you can. Let's drop it and see what happens. As you can see, the styrofoam floats on the oil layer, and I imagine this doesn't really surprise too many of you. All right, let me set this to the side, and let me return now to our bottle of Italian salad dressing. When we first looked at our bottle, we were just interested in the liquid layers. But now, let's look at the particles that we see in the bottle as well. And these are probably herbs or spices, maybe some chopped onions. But the point that I want to make here is, since most of the food particles are on the bottom of the bottle, the density of these materials must be greater than either the top liquid layer here or the bottom liquid layer there. There are some food particles, of course, floating in our bottom layer, and so these particles probably have a density very close to this bottom layer. By the way, the two liquid layers in our Italian salad dressing are these. The top layer is an oil layer, and the liquid layer is a mixture of water and vinegar. And as we learned over here, oil is less dense than water, and so it floats on water, and we see that is true with our Italian salad dressing.